Hi, folks. We're going to take a look at page 313, number 17. So the general gist of the problem is that right now, someone's selling 30 photos at a price of $10 per photo. Okay, but they did some market research and found that if the price is decreased by 50 cents, they would expect to sell two more photos. All right, so they want us to find a model for the revenue from the sales of this photo, then the price that needs to be charged to make a revenue of $150, and then the price for maximum revenue, and finally what price would they charge that would bring in no money. All right, so let's start with finding a model. Okay, now the way we're going to solve this is first of all to recognize how one makes revenue. Okay, so one makes revenue by selling, in this case here, photographs. So we're going to let our variable x represent the number of photographs that you sell, and then we're going to multiply that by the price per photograph. Okay, so here, first thing we're going to do is say let x be the number of photos sold. Okay, so it's very important to be very specific as to what the variable represents. Okay, now when we look at how the price works, every time I bring down the price by 50 cents, I sell two more photos. So that tells me that the price function is a linear function, okay, because it has a constant rate of change. So the first thing I'm going to do is determine my price function here. Okay, so since it's linear, I need 2 points to find the slope, and then I can find the equation. So I know that when I sell, okay, remember our x value is the number of photos, 30 photos, okay, we sell them for $10 a photograph, okay? But I can create another point on this function, okay? Because if I bring the price down by 50 cents, I'm going to sell two more photos. So when I sell 32 photos, that's because the price is $9.50. All right, so now I can calculate the slope of this function. So y2 minus y1, so 9.5 minus 10 over x2 minus x1, 32 minus 30. So that's just equal to negative 0.5 divided by 2, which is negative 0.25. So that's the slope for my price function. And so now I can find the equation of the price function. Okay, so since it's linear, it's going to look like y equals mx plus b. Okay, I'm not going to worry that, this really is P. I'm just going to use this as my model. So let's pick one of these points. This one looks a little easier. So when y is equal to 10, we found that the slope is negative 0.25. Okay, x is equal to 30, and then plus b. Okay, so now we can solve for our b value, and I'll do that on my calculator here. So what do we have? So here, when I bring this to the other side, it's going to be a plus, so it's going to be 10 plus 0.25 times 30, which is 1750. Okay, so that means that my price function is negative 0.25x plus 1750. But what I'm trying to determine is the revenue. So the revenue is the number sold times the price, which has this function representing it. So now I can expand and find my function. So negative 0.25 x squared plus 17.5x, and I see that I have a quadratic function. Okay, so there's my model. So now I'm going to use this to solve the different parts of the problem. So in this first portion, I want the revenue to be $150. So I just replace the revenue by 150. Okay, so let's see what we have. We have negative 0.25 x squared plus 1750x. So again, in order to solve this, I need 0 on one side. So I'm going to bring everything over to the left. So I'm going to have 0.25 x squared minus 17.5x plus 150 equals 0. And now I can use the quadratic formula. Okay, so here I've got x is going to be equal to negative b, so it's going to be positive 17.5 plus or minus square root of b squared minus 4 times a times c all over 2a. Okay, So before I put everything in my calculator, I'm actually going to simplify a little bit. Otherwise, it gets to be a lot to input in your calculator. So 17.5 plus or minus. So here, let's take our calculator and find 17.5 squared, okay, which is the same as negative 17.5 squared, okay, minus 4 times 0.25 times 150 is equal 156.25. So square root of 156.25 all over 2 times 0.25 is 0.5. All right, so now I can calculate my two possible answers. So it could be there's two answers. You know, if one of them turns out to be negative, obviously I'm not going to take that one into account. So we have 1750 plus square root of 156.25 equals, and divided by 0.5, and that's 60. Okay, so if I sell 60 photographs, I'll have a what do you call that? Sorry, a revenue of $150. Let's see what happens when I find the other answer, 17.5 minus square root of 156.25 equals, and then divided by 0.5, okay, or 10. Okay, so there you go. There are two valid answers. Okay, but now what I have to determine, if you look at the question, it's the price that gives me this revenue. Okay, so X represents, remember, the number of photographs. So if I want to find the price, I'm going to stick in 60 into my price function here. Okay, so negative 0.25 times 60 plus 1750. Let's see what that gives me. So negative 0.25 times 60 plus 1750, and we have $2.50. Okay, I should put an extra zero there. Or we have this same thing, but with 10 input there. So negative 0.25 times 10 plus 1750. Okay, so here we also have $15 would also work. Okay, so the question is, does it make sense to charge $15 as opposed to $250? I guess it makes sense to charge $250. Okay, although there's an argument to be made that I only have to sell 10 photographs if I only have to sell 10 photographs, so a lot less work. So either one of these answers would make sense. Okay, so the question is, do you want to sell more at a lower price, or do you want to sell less at a higher price? Okay, I suppose there's an argument to be made that, if you're a good salesperson, you'd like to give people the opportunity to buy these things at a lower price. All right, so let's take a look at part C. So here we want the maximum revenue. So notice here how in part B there was nothing that had to do with maximum or minimum, so I expected to be solving a quadratic equation, whereas here now I'm looking for a maximum revenue, so I should be looking to find the vertex. So I'm going to take my revenue function here and I'm going to find the vertex. So the first step in finding the vertex is to factor out whatever's in front of the x squared. So negative 0.25. Okay, and I'm left with x squared, and this is going to be minus, well, let's do 17.5. 17.5 divided by negative 0.25, so negative 70. Okay, so minus 70x, and so now I'm going to complete the square inside this bracket. So it's x squared minus 2 times, this is going to be 35, so I'm going to add 35 squared and subtract 35 squared. Okay, so here, negative 0.25. Okay, so I'm going to end up with x minus 35, 35 squared, and then here minus 35 squared. Okay, so now I distribute the negative 0.25. Okay, and I'm going to be left with some addition here. So what do I have? I've got negative 0.25 times, I'll just do the 0.25 times 35 squared. since I know that it's going to be positive, and here 306.25. Okay, so let's look at the actual question. They didn't ask for the maximum revenue, they asked for the price for the maximum revenue. So it means I need to sell 35 photographs, and let's put that into our price function. So negative 0.25 times 35 plus 1750, and that's going to give me negative 0.25 times 35 plus 1750 is 875. So 875 is the price that's going to give me the maximum revenue. All right. So now the last part is what's going to give me zero revenue. Well, I can think of one answer that should be obvious. If I don't sell anything, I shouldn't make any revenue. So let's see if that works here. So D. So now I'm going to take my revenue function, but I'm going to place R by 0. Okay. So here, this is, but I want you to look at this revenue function here. Look at this other way in which we wrote it. It's already in factored form. Okay, now one of the ways to solve this, instead of using the quadratic formula, is to use factored form if it's at all easy. So in fact, this is a little easier than what I might have thought, because I can already write this in factored form. 25x plus 1750. Okay, and so now I have two possible answers. X can be equal to 0, okay, or I can have negative 0.25x plus 1750 equal to 0. But remember what this represents. This just represents the price, okay? So obviously if my price is equal to $0, I'm going to make zero revenue. That makes sense. It means I'm giving away the photographs. All right. But the other option is if I sell no photographs. So if X is equal to 0, let's find our price that's going to give me no photographs sold, meaning if I make it so expensive that nobody wants to buy it. Okay, let's see what happens. So now if X is equal to 0, I'm going to put that into my price function. So what do we have? Negative 0.25 X, which is 0, plus 1750. And of course, since this is a linear function here, I expect it to just be the y-intercept. So I think I accidentally pointed at that one for price. This is obviously the price function, 1750. Okay, so obviously if I don't charge anything at all, I don't make any revenue. But if I charge 1750, what does that tell me? It tells me nobody's going to buy the photographs, hence I'm not going to make any money. Okay, so in some ways this is the more reasonable answer to this question, because nobody would just sell something for nothing at all. You're giving it away. Whereas if I sell at 1750, it's saying that I'm charging too much. Nobody's going to buy the photographs. Okay, so just to do a quick recap here, and I'm not going to go through all these parts, but I would just go as to how we come up with our model. Okay, so step number 1 is to realize that revenue is the number of items times the price that you're charging. Okay, but the price function is a linear function, because every time the price goes down by a certain amount, okay, the number sold goes up by a certain amount. So you can use that information to find a price function, okay, and then stick that into the revenue function and work with this equation. Okay, the other thing I want you to remember is that when I'm talking about maximum or minimum, I'm finding the vertex. When I'm not talking about maximum or minimum, I'm solving a quadratic equation. And I could solve via the quadratic formula, or I could solve via factoring. Okay, that's it for this one.